I'm really excited to introduce our next guest, who, from what I understand, is back straight from the Himalayas very recently, Anirudh, who is here from Pinterest. And I think we'll be talking a lot about the journeys that Pinterest has taken in terms of productionizing prompts. So really happy, and thank you very much for being here.
Thank you. Feel like a singer here. So I have been out of internet's reach for the past 2 months. So I'm getting that FOMO coming here. So one story is we are able to launch at an O'Reilly book, which got translated in Japanese, and we are able to launch it on top of Mount Everest as the world's highest book launch party. And I've seen those photos of 300 people waiting in line. That was the party. But the book actually mentioned about Ludwig and Horvath. So you're technically there, and your team was there in a way.
Not the Himalayas, but in the book. Yeah.
In the book, yeah. So hi, I'm just trying to have fun with the title. It's the practical path to productionizing prompts at Pinterest, because it has all the 5 Ps, and it hits a good title. So the talk is going to be a little bit technical, but also like the strategy of building, enabling your employees to be the ones building and thinking about what next to build instead of one team doing that. So I think that's the key takeaway from the talk at the very end, and it gets in high action in like 3 minutes. So Pinterest is a visual discovery platform, which I hope you have seen before, heard before. We have about 570 million users. And as 2023 came, one of our goals became from prompt to productivity as quickly as possible. So to showcase just at the base of the underlying way of building some of these platforms, we like to have 3 things. First is a multimodal vendor strategy. So this is a short diagram showcasing the different layers that we have, and essentially we have built it in different layers to take care of different tasks. So the first one being allow having multiple models inside. So whenever someone says, hey, I want X model or Y model, we're able to bring them quickly and onboard them quickly. But then we have a centralized proxy layer where we then decide, do things like rate limiting, integration with the vendors, properly logging. That helps in the proxy side of things. And this also helps us to see, if some employees need a new unreleased model available versus like there are general models that should be available to everyone, we can really administer that. And then finally, we also want to build things scrappily so that the common tooling can be given to people as soon as possible. So that's the layer at the very top, where we have environments for developers, prompt engineering tools, internal APIs, bots, assistants, and things that employees can use. And then finally, we also want some centralized guardrails. So that's the other layer where we have empathetic AI checks, safety checks, content quality checks. And this is what we started implementing in 2013. And because of this layering, it was easy to add things over time and fit in the strategy of enabling employees to do more. And now starts the journey. This is the journey. Mistakes were made, but we have something at the end which hopefully you will like. So when we were starting out, and the buzz for GenAI was there, but not many employees had used it. So the first thing we did is we dressed up in Halloween suits, and we called ourselves the prompt doctors. And the idea is that, hey, we have some experts in the company that you can talk to help accelerate your use case. We diagnose problems, prescribe solutions. And every time you talk to us, we would make puns about something and a medical pun. And the first thing we started was have a gigantic live class for people in the company to dispel what GenAI is. So last year, as an example, llama, the model. So I literally drove to a llama farm at 10,000 feet and held this class. We had 1/3 of the company join in, And the interesting part is 1/3 of the company, this is not like mandated from the top. This was just organically word of mouth on which like people have seen this happen. So we just have fun with the teaching style in these courses so it doesn't look dry. You take them through both prompt engineering skills, what it does when it makes mistakes, hallucinates. You show them the goods and the bads. And the reviews were really good on that. Like, this does not sound like a training class. That was a trick to get us in the room to teach us. So this was an insane way to start. But the next thing we did was even better. We held a hackathon the week after where we gave every single employee in the company 3 days to go build whatever they want. So what you just learned, we are giving you the time to start using those skills live. The one other thing we did is we just didn't tell them these are prompt engineering skills, but we started showing them no-code tools. This is 2013 for reference. No-code tools so that you can start building apps without coding. You can do things faster, prove up the concept. And then we mix this with our planning cycles. So you go to the class, learn some skills, then go to the hackathon, build something, and then right after that, there's somebody evaluating this, that can this be built in our product plans? So that circle allowed people to go from not knowing about GenAI to having something that could be valuable in a matter of about 2 weeks. So the next part is, I think this point has already been talked about, which is Pinterest. We have about 300 machine learning engineers. They have been working on transformer models before. There was an article in 2022 about 100x sized models that are now running in inference. But when you talk about machine learning cycle, every time you work on a problem, you have to go through the whole cycle of training, building, inference. It takes a month plus at least, if not more. But now you find that if you have the world knowledge and understanding already, writing a prompt can give you enough value. So this is quite promising for accelerating things to being shown as a proof of concept, at least. So prompt engineering is a common theme in this particular talk today. So same thing at the hackathon, we found that a lot of teams has these machine learning data sets. It's stored in a Hive table. And if they could just write a prompt, they could do something with it. But if every team starts to learn how to use these APIs, this is going to take a long time, and we don't know what quality it would do. So during the hackathon, we built a simple Jupyter notebook where you, at the very top, just write your prompt, select the Hive data set you have, and it starts to label data for you right then, right there. So all you need to do is just edit 2 lines. You don't even need to be technically for that. So we built that. But then we started looking at the logs of who are the teams who usually train these machine learning models, and then just started going to them and giving them an offer they couldn't refuse, like in The Godfather, that if you have a 1-hour meeting with us, you can start using this self-serve notebook and solve your problems and maybe accelerate it and get that credit for it. So as we started doing this, we had about 40 meetings that would just come up of meeting people, learning their use case, but in 1 hour trying to solve their problem. But in 1 hour is the key that we are trying to stress here. And as we are learning from them, we are starting to build more and more tools in our arsenal that could be useful. So it's kind of like a self-fulfilling prophecy that we are building for these teams. But this is Jupyter. This is not scalable, right? But those 40 use cases that we got started using this, which got us enough ammunition to then get a team funded to build things at production scale. So we built a batch labeling system where, again, you don't have to do anything other than bring a table and a prompt, and it starts to, at high throughput, start labeling data at speed. Just because of how quickly it got adopted, it became the fastest adopted platform at Pinterest. So have those 1-hour meetings with your customers, because you don't know where this would go. Behind the scenes, it abstracts away the labeling process with any vendor in the middle, or if it's open source models in the background. So people can organically start to think on the use cases that they have, and this has been quite helpful in that process. But remember, I said table and a prompt, and then whatever you want to label, it happens. So then this was a good start. But then we wanted to see what's maybe the friction point still in this whole journey. So we had a user research session where we started observing engineers, product managers, analysts, scientists, designers on like how do they start thinking about a GenAI product. And there was this is like a timeline of basically what happens when they have to go from start to end. But basically, they go to an open source tool called QueryBook, where they download that data that they have in the tables. They sample it. Then they upload it to a tool for doing like basic prompt engineering. It runs those prompts on a data set of, let's say, 1,000 size. Then they download those results and then upload it to a spreadsheet software, essentially copying, pasting that CSV file. They conduct evaluations, so human labelers would then say, okay, this is yes, no, or whatever categorization they have to do. And then they copy paste the prompt in an online editor so they can version it. And then they go back in the editor with improved prompt and then run this whole process. So this is your prompt iteration, but because you need an evaluation to know, that's what they are doing. Now, let's say you actually had a good prompt. You reached those good numbers that you're waiting for. Then they would go to the scalable tool, for which they still needed an engineer to like turn it on. They would create a configuration file in order to run that batch labeling system. So some people who are product managers still had to call an engineer to get that running. They would wait an hour or two to see how the data ran, and maybe there are errors. If there are errors, they go back to fix the file. You know, things that happen in every engineering project. And finally, once you have that data labeled, you sample data to see quality. You do evaluations on the trust and safety. There's hallucinating. Are there AI safety checks? It's a lot of steps, essentially, that we saw observing the users go through that. Well, you can obviously see many of these things could be done in a more easy way in one place. And so for that, we started noticing scattered tooling. Version management is a problem. Golden data sets is a problem. Standardized testing, collaborations were common problems that almost everybody faces, but because nobody talks to others, they just don't realize all these problems. So for that, we built a toolkit called PromptHub, and which is exactly going to solve these problems. Essentially, if you can bring in a data set, you can centrally bring any of the hundreds of thousands of tables in this particular tool. So now you have like a saved, data set against which you can write the prompts in the left side. And then when you run it by selecting, it starts running it against any model that you want. Now, as you're running it, the evaluations are happening. So you can see the accuracy or whatever metric F1 that you care about. But at the same time, it also shows the cost per millions for your particular prompt and that particular model, an approximation here. So the beauty here is that once you have built this, it's a centralized leaderboard. And if it's a centralized leaderboard, you can try any technique. You can fine-tune a model and essentially see how that's performing. You can write a better prompt and see how it's performing. But it's like one place where you can see how your team is iterating on prompts. And for leaders, it was a way to see like have that eternal question of are we there yet? Because you can actually see on this prompt leaderboard that we yet are not. So this was quite helpful at the start. But this is the beauty that now we can, if you have the registered data set to test against, we can then fine-tune it, test against a distilled model, try a variety of things. But at the end, we have a centralized way to check your performance. And lastly, then we have a single button that if you think you are ready, you press that button, and it will scale up and label millions of items with the press of a button. So no engineering required is the TLDR, simplifying. So I did mention the leaderboard. And this was purposefully done because now when you register a data set and a leaderboard against a problem you want to solve, almost all problems in at least our company are publicly, internally visible to employees. So which was the next part of it, which is like, can we democratize problem solving? So we started putting some of these challenges of like, here's a team which is trying to solve a problem. Well, we just give a bounty for solving it. So you have like a specialized prompt engineer trying to solve it. What if we get like all the employees from the company just try to solve that as as a good exercise. So what we did is we again went to that hackathon mentality. We gave a class on prompt engineering. We said, oh, here are all the good companies saying how you should be learning prompt engineering. Oh, you want to test it out? Here's a real problem. And you get the credit if you are able to beat our best prompt engineers, and you ship them in production. So you get the credit for that. So we did that. What we did is we gave them a starter prompt. So in this, you can see, just like Kaggle, we had a secret test set. We have a starter prompt, a hello world prompt to solve that. And then I'm showing you here the previous best prompt, which had taken 2 months to curate professionally, and the cost of that prompt, in cost per million labels we would get. In 24 hours, we essentially had people beaten that work that had been professionally done in 2 weeks, because they came up with different ideas on how to solve the problem. They were pretty ingenious in the ways they approached it. And you can also see the cost of, it was not just the accuracy was beaten, but the cost on this particular problem was beaten. By the way, this was a hard problem. I know it's in the 40%, but it was actually pretty good for being in the 40s. So that's good. So opening the problem to your employees, and I think the rank 1 or rank 2 is from a finance team. It's not from engineering, product, anything. So people are getting I have ownership in this. And then we gave them prizes and awards for multiple projects. But then there was one entry we got which actually beat all the other participants also, and it was pretty cheap there too. What we didn't tell people was that behind the scenes, we actually had a secret AI employee who was also in the same contest as the humans. And so that's my ploy for talking about Autoprompter. Okay, so LLMs are good writers, obviously. We got our assignments written with them, but they're also really good prompt writers. So here's a simple example where if you just look at the bottom, I'm going to give it an input and an output. Hell is hot, Antarctica is cold. Chili peppers are hot, flu is cold. Lava is hot. And then at the very top, you say, write me a detailed prompt which can help translate input to outputs. Here are the input-output pairs, right? It understands the context, and it's now writing you a prompt which you can then run on an LLM. And it's like you're an expert at classifying prompts, right? And it gives you this really, given a single word or short phrase, it kind of guessed that. Instructions at the very bottom, do not provide explanations, please. So that's great. So they do a good job. So the question is that can you now use them to generate better and better prompts and beat those humans? So I'm going to give an example problem so that we can see this in action step by step. So here's the problem. It's essentially, if I show you an image and I show you a query, like a search query, is this term related to that photograph? So in this particular example, there is a photograph. Make whatever you can out of it. And then there is a query, which is corner DESJ. And your job is corner DESJ relevant to this? So here, you can run an image caption first to get a caption out of the image, a text to image to text problem. And then you can just write it inside, insert it in a prompt, reply back with a yes or no. Is this expression corner desk relevant to the following sentence? And you can solve this problem, right? So I'll go back to, I didn't talk about this, but neural networks, we're going way too back. But neural networks, the way they work is you first make predictions in the forward pass, and then you pass the gradient back propagation to learn from the errors, and you keep doing that in an iteration circle, right? So what if you had the exact same thing, but in terms of prompts, where you had a student and a teacher, and the student is writing these prompts, and the teacher is telling them all the errors and propagating it back. So think of it as a gradient is the error it's passing back. It's a text gradient, essentially. So let's think of this as predict, critique, and refine. So here's an example. It says, is the query relevant to the pin? That's the question. Frozen, is it relevant to frozen margarita recipe? It said it's relevant. The LLM said yes, but turns out it was wrong. And it got some accuracy. So the teacher says that, what, one of them might be related to a Disney movie, while other might be related to food. And then it gives back the gradient that relying on exact keyword matching can lead to 13% of the errors. Now imagine you had like 100 examples or 1,000 examples, and you could like make those examples in a priority list of which is the biggest mistake, which is the least mistake, and pass it back to the student. And the student now learns from it, ensures thematic similarity, even if the keyword matches, and it made a correct prediction. So you start with a prediction, generate a prompt, you get a critique, and then you refine the prompt back, and it's two agents talking to each other back and forth, back and forth. They have access to a couple of tools also. So here's an example. I started with determine the relevance of search queries to image captions. That's what I gave it. It gave a big critique. It says too verbose in output. It's misinterpreting the task, and then it gave it suggestions on how to improve. So the student now incorporates the suggestions and come up with like better. It seems to be a better prompt, right? If you just look at the length of it, but it's still at 0% accuracy. So the teacher says, you know what? The problem is you're generating way too long explanations, even if you just had to say yes or no. Fix that. Next time, it actually fixed it, and it went to 65% accuracy. I'm showing the diff of words in that green color slide to slide, but as you'll just see, it's giving these long critiques, and now it goes from 65 to 69, and it changed those words in that green color. It says broad sense, include thematic, contextual, and visual connections. We go another pass, it goes to 74% accuracy, it's improving. And now at this point, we got to like 75%, which was pretty hard for this problem. But you can see like how that prompt, if I just go back, went from here, a single line we gave it, to increasing to this big length. It's asking for all these intricacies in how it should evolve. That's the high-level idea of two agents talking to each other, being pals, and there can be a Hollywood movie about that, honestly. So this is an example of like running it in PromptHub, where we have we gave it that initial prompt, we gave it that data set, and it went from 39% to 81%. And as you're running it, it gives you the cost because it has to obviously run through all these different APIs. So the number of calls, the time it takes, it gives all these interesting insights. And here's like a learning graph as you went through from start to end to come up with a really great answer. One interesting thing is the beauty, if you realize here, is remember I was talking about those leaderboards at the end with an evaluation metric already set? If you had that, could you not run a cron job so that anytime you hear a new model that has been released, you could just get the autoprompter to write the best prompt for that model and then ping the user on Slack that, hey, I beat you twice in the last 2 weeks, and here's a new model which can do even better. And then you decide as the owner, like the cost, the cost versus the accuracy level, like would you want to go for that? So centralizing your data sets, centralizing your evaluation has been helpful in so many ways. And the best part is now the people who have registered here, we don't even need to talk to the team or have a meeting with them to actually enhance their use case, because we can just do it behind the scenes and then call them and say, hey, we have a better solution for you than you had last week. So centralization definitely helps in that sense. We have had users, professional prompt engineers, who basically, imagine you're working on a problem for 2 months, like how would you improve that further, right? And then you use this, and like in 10 minutes, you have a full 4% improvement. Like they're like, where was I? Why didn't I use it in the first place? So they often start with this initially, and then once it has reached a plateau, that's the point they start fine-tuning the prompts at that particular end. So that's nice. Okay, some philosophical learnings to end the talk. We found that simplification accelerates adoption. Sure, you can give them the API, but if you can give them a GUI, even better, more people will be using it. Oh, it's a button press. You don't have to talk to managers. You don't have to get permissions because everything is happening in the background. It helps. Maximize deterministic paths and agents. So if you especially have worked with a open-ended agent to solve problems, it can go in all different directions. And if you plot a success rate for an agent, it's not that great for open-ended problems. You narrow it down, it keeps getting better. So the first time we started, we actually tried to make it like go all directions and saw how it was reaching success in auto prompting. And the things it was doing really well, we just converted into a workflow. So deterministic things help reach success more often. Give people dedicated times for grounds-up innovation. So you teach them a class, but then immediately give them 3 days to pursue their dreams. It helps. Every engineer is a GenAI engineer. We don't have a team which does GenAI at Pinterest. We just expect it's part of your job if you are an engineer there. So you find a use case that you think you can, do better on, and then go make it happen. One of the assumptions we have kept in all the things is that whatever we are going to work on is going to be outdated in 6 months. So have no ego about it. And then every employee, and I especially mean every non-technical employee, is one prompt away from the next breakthrough. We had a sales employee who was trying to solve their own problem and finding the right document to get things done and finding the most updated answer. And she ended up, in the attempt to solve her problem, building a Slack bot, which does RAG, and now it can do information from Jira, GitHub, be able to file things there, and it's like one of the most used tools at Pinterest. But it was started by someone who is not technical because they could write a prompt, they could test that this can work, and then more engineers started to help in that project. Another good example we found is like our top prompt engineers don't have a technical background. How it started with a BA philosophy, how it ended as a GenAI solutions architect. People with linguistics degrees, I can see why they can communicate to computers really well. So don't forget to communicate like humans. By the way, it's really helpful. You ask ChatGPT, you give it a prompt and ask it, what are you confused about? It will tell you what you could add to the prompt to do better. And obviously, lastly, keep a good support system that people actually want to use. They're excited to use. So that's our Halloween suit where we had a call line. People can just call up. We had medical jokes on this to brainstorm ideas, fine-tune models, find a path to production. So people would just anonymously call this hotline, and I would show up. And in the last 1 year, we had 200 sessions of 1 to 2 hours to solve these problems. And people were able to accelerate their use cases by like 6 months. Their plan, I'll do this next year. And I said, you can do this week. You just haven't thought about it. So these things help. So thank you for listening. And I hope you have a great, happy prompting journey.
Anirudh, I want to thank you for that talk, but during it, one of our engineers pinged in Slack, when are we getting a llama budget? So I feel like I'm going to have some things to explain there. Do you have a few minutes for questions?
Yeah.
Or great. I think we might have time for about 2 questions, if anybody would want to ask. From the DoorDash team.
Hi, Rohan from DoorDash. Thanks for the amazing talk, super interesting. I was curious about the eval setup. So, you showed some cost and didn't seem too high, even though you had a bunch of iterations.
Mm-hmm.
Of course, evals are super important, especially when doing this automatically, and then the costs go up. So how do you control for costs while doing good evals in this super automated process?
So usually we do it on a small set of 1 to 5,000 labels that we are generating. So that's usually peanuts compared to the real whale later on. We also run this against other evaluations. So we do a trust and safety checks, and we'll give the toxicity score for each one of those outputs that has been generated. So people can say, yeah, this is a good iteration, more accurate, but at the same time, it's saying things I don't want people to see. So we have many dimensions where cost comes in. And for cost, it's an approximation as people start off. So for example, if you know how many parameters this model will be, and after quantization, we have some rough estimates of it, we're able to build an estimate for that particular model.
And if you could please introduce yourself.
Hi, I'm Evelyn. I'm a former product manager turned founder. So I do have a question about the pain points that you have faced in this awesome process. I know that everything has been so accelerated. However, when it comes to comparing how we used to do things prior to this, the rise of AI and how everything turned into prompt engineering and empowering teams to do so, how are we looking at documentation? Because documentation and context preservation is very crucial, I think, on the long run, even though today we're after those short-term wins, which is very important, but how are we looking at context preservation through documentation?
That's exactly the hackathon project I have this year. So documentation is important. We actually built a bot to check if when you check in code, does it have at some point what's the documentation score for what you are checking in as the customer would use it. I think there's a common problem, you have documentation, then you create a new file with a better version. So we have Docathon days every quarter where our job is to delete documents. Of all the hard work our PMs have done, we delete it because it's outdated, and then we essentially try to update the information. Call it spring cleaning once every quarter. So that has been helpful. We also have, in one of our RAG systems, we have a score for when you get one system saying one thing and another system saying another thing, and they are completely orthogonal to each other. So when we notice this, we actually flag it to the owner of the documentation that is this true as a Slack message. So that's possible there too.
Awesome. Anirudh, thank you so much for joining us here. That was a fantastic talk, and welcome back. And I'm really excited to see you in that doctor in medical suit as well.
I might take a quick photograph so my manager doesn't know I'm here, so he has some proof. So let me do that quickly. Thank you so much.